So the other identities that are related to the sum difference formulas are going to be the double angle formulas. So you can see I've written them there. We've got a formula for sine 2a and for cos 2a. And what we can do is actually just prove these identities as if they were identities. So let's start with the first one. Sine 2a equals 2 sine a cos a. And so the way that we're going to prove these, well, as always with all identities, I'm going to split them up into right side, left side. And so what I'm going to do is actually use the additive formula. So that sine 2a, I can actually rewrite that as a plus a. And then that's going to allow us to use the additive formula for the sum formula. Spelled that wrong. And so that's going to be sine of the first, cos of the second, plus cos of the first, sine of the second. And then hopefully you can see that those are the exact same term. What we've got here is exactly 2 sine a cos a. And that would be it. That works out quite nicely. So for the other formula, it's going to be really the same thing. But what we will see, we're going to actually generate a couple of additional identities out of this. So the left side, I'm going to do the same thing, write that as a plus a. And so if you remember the left side, it's cos of the first, cos of the second, which are both a, minus sine of the first, sine of the second, which are again both a. And hopefully you can see it's exactly the right side. It's cos squared minus sine squared a. So that actually works quite nicely. What we can do is actually get a couple more here for that cos 2a formula. So actually, if we go back now and use the Pythagorean identity, sine squared a plus cos squared a equals 1, there's two things that we can do with this. One of them is we could take that cos squared a and write it as 1 minus sine squared a. And then what we actually get is 1 minus 2 sine squared a. So I'm going to add that up here. And we can do the same thing with the sine squared a. I can actually swap that one out for 1 minus cos squared. And then what we end up with is 2 cos squared a minus 1. So those are all actually equal to each other and sometimes useful to use different versions of it. So I'll have 2 cos squared a minus 1. So again, you can generate the 3 just from the first one by just using the Pythagorean identity, but sometimes it's nice to have all of them in front of you. Okay, so some problem that we can do with this, we're given here that tan of a is negative 24 over 25, and a is in quadrant 2. And so we want to find tan of 2a. There is a formula that we could use for the double angle on tan, but I don't want to know more formulas than I have to, so I'm just going to split tan 2a into sine over cos, so sine 2a over cos 2a. And then I should be able to actually just use the formulas that I'm given there. So that will be 2 sine a cos a divided by, it doesn't really matter which of these formulas I choose because I do need to know both sine a and cos a for the top already. So I'll just go to the default one, cos squared minus sine squared a. And so yeah, so I'm going to have to figure out all of these, so sine a and cos a. And to do that, just like with the additive formulas, we're going to use this information that we're provided about tan. We can draw the triangle, we can find all the side lengths in the triangle, and that should give us, yeah, I think everything that we need. I just realized that I didn't choose the numbers well, so you're gonna have to bear with the fact that we're gonna get radicals in this, unfortunately. Yeah, so I'm gonna set this up. It's in quadrant 2, so it's gonna be on the left. That means that my x will be negative 24. I really wanted that hypotenuse to be 25, but I wasn't paying enough attention, so there we have it. And so the hypotenuse is going to be 25 squared plus 24 squared, root 1201. Ugh. Which, as far as I know, isn't going to simplify at all. But that should be enough to get my sine A and my cos A. So sine A is 25 over root 1201. And cos A is negative 24 over root 1201. But I looks like at least all those roots are going to sort of wipe each other out when I plug them in. So that's nice. Yeah, so I'll get 25 over root 1201 times negative 24 over root 1201 divided by, so cos squared, negative 24 over root 1201 squared minus 25 over root 1201 squared. And so I'll just clean it up. 2 times 25 times 24 is 1200. So negative 1200 over 1201. The roots are going to cancel. And then what I'm going to have is 24 squared, as the negative is going to cancel with the square, minus 25 squared is negative 49 over 1201. And then the 1201s are going to cancel. So I actually end up with 1200 over 49. And as far as I can tell, that doesn't look like it's going to reduce at all. So yeah, so that should be my tan ratio. Yeah, that should actually give you one of those Pythagorean triples. If you do 1200 squared plus 49 squared, and I take the root of that, yeah, we end up with 1201. So the hypotenuse of that triangle would be 1201. So it's kind of nice. So that's one thing that we can do with these double angles. Right, so something else that we're going to be able to do now with these double angle formulas is possibly now open up some more equations that we're going to be able to solve. So this equation here, I've got 3 cos 2 theta minus sine theta minus 3 equals 0. So there's a big glaring problem with this equation that we've got different inputs on the trig function. We don't like that when solving equations, so we need to kind of make some fix on it. And so the easier one to sort out here is going to be that 2 theta. I'm going to fix that 2 theta. And so that's going to be my double angle formulas for cosine. And if you're remembering some of the principles that we've talked about with equation solving, we usually want the same thing showing up again and again. So in particular, I'm going to choose the version of the double angle formula that only has sine in it, because if I have coses as well, that's a whole other problem that I'm introducing. So I'm going to replace with just the one with sine, and that way everything in my expression is just sine thetas. So what I'm going to do is swap this out. 1 minus 2 sine squared theta, right? Theta instead of a, minus sine theta minus 3 is 0. And this should just now make a quadratic in sine. So I'm going to get 3 minus 6 sine squared theta minus sine theta minus 3 equals 0. And I think I've possibly made another careless mistake, but we can deal with this. So I'm going to move everything to the right so that my sine squared is positive. So I'm going to get 6 sine squared theta and then plus sine theta, and actually, yeah, so the 3's are going to cancel. Yeah, I'm good. I'm okay with that. All right. So those 3's are going to cancel, and what we actually now have is just a sine squared theta plus sine theta. And so to solve this, I could factor a sine theta, since there is a common factor there. And that would give me 6 sine theta plus 1. And so that's going to give me 2 solutions here. Sine theta is 0. Not 2 solutions, 2 equations. Sine theta is negative 1 over 6. So sine theta equals 0. I'm going to use the graph of sine to figure that one out, but hopefully you remember 0 is a solution, and then we get another solution over here at the halfway point of the period, so at 180. So I'll get theta is 0 degrees or 180 degrees. And the sine theta equals negative 1 over 6. So this one I'm going to use a triangle. And so sine theta is negative means that it's going to be on the bottom. So I'll have negative 1 and 6. And negative 1 and 6. And if I use a calculator, I would get theta is the inverse sine of negative 1 over 6. Or you can use the 1 over 6 to get the reference angle, but this should get me one of these actual solutions or something close to it. And so if I plug this in, it's actually going to give me negative 9.6 degrees. So that's not in my range of 0 to 360 at all, but it does tell me that the reference angle is 9.6 degrees. So that does tell me that this is 9.6 and this is 9.6. And so for my 2 actual solutions, I would have 180 plus 9.6, and I'd have 360 minus 9.6. So my 2 solutions will be 189.6 degrees or 350.4 degrees. And so, yeah, so my whole solution set, 0, 189.6, 350.4. Oh, I'll write the other one first, 180, just so that they're in order. And 350.4 degrees. And so, yeah, that should be all of the solutions for that.